variable. Okay, whenever your differential equations involve more than one independent variable, their partial differential equation comes. Okay, so here differential equations involving differential operator. Okay, okay. So you can say dy by dx plus x equals to 2 this way, this kind of things. Okay, so here we will look at the first order first degree equations. You know about the order of the equation? What you can say about the order of this equation?
And one.
First order.
One. Okay, the highest order derivative present in the equation. Okay, I'm talking about only the differential equations. OD. Okay, we will say ODE, ordinary differential equation. So it's the ordinary differential equation when you have only one differential equation involves only one independent variable. Now, if it is more than one, we will have the partial differential equation. And in our course, we will be only talking about the ordinary differential equations. So order, when we talk about the order, we have normally we have the function y equals to fx, and this is dy by dx. So you can also have d2y by dx square plus dy by dx whole square. Sorry. So let's make it whole square plus 3x, okay, 4x square. We can have terms like this. So what you can say about the order of this equation?
Second order.
And what is
Second
the
order.
degree?
One.
So
One.
degree is 1.
One.
So how we find the degree? So a degree means we will look at the degree of the highest order derivative. Okay, this one is of degree 1. Okay, so suppose you will be having only this term q plus x square equals to x plus 2. Then we here what will be the order here? Degree?
Order is 1 and degree is 3.
Order is 1 and degree is 3. So order means the highest order. So highest order derivative present. Okay, or the differential coefficient. Okay, and degree means we will look at the degree of the highest order derivative. So it's the degree of highest order derivative. Okay. So this much you know about the differential equation. Okay, so in our course actually we will be looking at the different methods to solve this differential equation. We will start with the first order first degree equations. Okay, so the solution we will try to find out. We have some certain typical methods. Those methods we are going to discuss first. Okay, so here first we will start with first order first degree equations. Okay, so first order first degree equation means we will be having only the dy by dx. Okay, and this will look like dy by dx equals to f of xy. Okay, this is first order first degree equations. And we will look at different methods to solve this one. Okay, so without much delay, we will start the first method. I think many of you know this one. It's known as the variable separable method. It's the first and easiest thing. Okay, variable separable method. So by the name only you can understand we will try to separate the variables. So that means we have one independent variable, one dependent variable. So what we try to do, we will try to keep the one variable in one side. Okay, like here y, so y in one side and x in other side, and we will do the integration. Then we will have our solution. Okay, so it's the so here the form will be like this. Okay, so here differential equations of this form. Okay, these are the already this is known as the in one side we have y variable, in one side we have x variable. Okay, and the solution is given by, okay, either it will be of this form, and sometimes you are able to reduce it to this variable separable method by taking the corresponding variables to their side. So the solution of this equation is given by, is given by okay, we will integrate it simply because we have one side y variable and one side x variable. So we will integrate it and we will have the constant of integration. So this will be the solution of the differential equation. Okay, we can try and look at one example here. Okay, see, solve dy by 1 plus y square, and here dx by 1 plus x square. Okay, so this two you will solve. Okay, so how? Try and integrate. It's a directly, see, it's given to you in a variable separable form. In this side we have y variable, in this side we have x variable. So what is the solution? I think you can say this one. If you integrate, what you will be getting? All it the variables are
tan
separated.
inverse y.
Tan inverse y equal to
Tan
tan inverse
inverse
x
y
plus
equal to tan inverse x plus
Oh,
3.
Sneha, you say
Yes, ma'am. Tan inverse y is equal to tan inverse x plus
tan
3.
inverse y equals to tan inverse x plus the constant. Okay, so here we have the solution. If you want, you can further, if you want, you can leave it in this form and you can further write it. Okay, you can write it in an algebraic form. You see, okay, how you will do this one? If you put it in an algebraic form, that will be much easier. Okay, because otherwise you have to solve for the tangent. Okay, so here it will be c tan inverse y. Can you do it? Reduce it to the algebraic form and you have the c. This constant you can write it as tan inverse k. Now you can do it. What you are getting? Combine this tan inverse A minus tan inverse B form. So what you will have here?
Y
Y
minus x upon
upon what?
1 plus x.
1
1
plus
plus
x
sy
1 plus
1
y.
plus
Right.
xy. And
equal
here
to
tan inverse K. It's always preferable. If you are, I mean, if this form is there, you try to write it in algebraic form. Well, it's a comparatively easier one. Okay. There's a tangent, solving the tangent will be much more tougher. So K into 1 plus xy. Okay, so this is the solution. Okay, so here you can try one more. Solve x into 1 plus y square dx minus y into 1 plus x square dy equals to 0. Okay. So it's again easier one. You can separate the variables in both sides. Okay. So here, what we can do? Well, y and
1
x we
plus x
will
square upon 1 plus y square.
y upon 1 plus y square dy. So you take it to this side, then divide it by this y plus y square to that side, right? And here x by 1 plus x square dx. Okay. So now how we will get the solution? We will integrate it y dy by 1 plus y square. So if you integrate, what you will be getting?
1
What is
by
the
2
form?
into
Ln y
Half
plus
log
y square.
1 plus y
ln
square.
y
Log
square
1
to
plus
can
y.
by 2.
Okay. Log 1 plus y square equals to log 1 plus x square. And the constant, if you want, you can write it this form, because we can also reduce
1
this
by
logarithm to the
1 by 2
form.
square
Yes?
It would be half log of y square. No?
whole
2y.
square. Answer plus
Half of it
Yeah,
we cancel.
what did you say?
half log 1 plus y
Half
square.
log of 1 plus y square.
So that half you can adjust in the constant.
Yes, yes, ma'am.
Yes.
Okay. So 1 plus y square. So this one, you multiply both sides to 2, it will get cancelled. What it? Here half and here half. You will write
Okay, ma'am.
2y, 2x. So you don't have that one. Okay, so it will be c into 1 plus x square. See, look at this one. If don't put it in transcendental form, if those things are, you can write it in algebraic form. Okay, and solve this one. So here the question is x dy by dx. So differential equation is like the methods we are going to discuss. It's uh, very beautiful and very easy. Okay, so you can try here. What will be the solution?
Y equals to sine of ln x plus c.
Y equals to sine of. Okay, so you can further write this one. Okay, dy by 1 minus y square, and this will be dx by x. Okay, so if you solve, you are getting sine inverse y equals to log of x is constant, and this will be y equals to sine of log x plus c. Okay, so this is your solution.
You can also write c equal to log c, no, ma'am.
Yeah, then you will be log xc. Okay,
HC.
so sine of that will come. Okay, since log I am not removing, I didn't write. You can write. Okay, so the you will now next we will come to the homogeneous equation. Okay, you said some of you that you know homogeneous equation. What is a homogeneous? So this is how you should do the variable separable. Okay, you take one variable, you keep one variable in one side, and you do the integration. Okay, next we come to homogeneous
Degree of
differential.
whole equation is constant.
Degree of the whole equation is same.
Degree of the
Whole equation is
All
constant.
the terms degree is
All the
same.
terms degree are
Degree
same.
of numerator equal to degree of
constant.
denominator.
Okay, so the other way, if you write it this way, normally if you go for the equation, it is tx ty, and you can take this t power n here, and you will have xy. Like in every term, you should get a power t power n. Okay, so this is how. So degree of each term is constant. If this that one is for the normal equations. Okay, so f of xy is called is
Homogeneous.
homogeneous of degree n. We say homogeneous equation of degree n. So this is for the normal equations. Okay, and what about this differential equation? What you can say about the homogeneous differential equation? So here examples, you can say x square plus xy equals to 0, right? Then cot inverse y by x. This is also homogeneous. So here, if I write degree, this one, I didn't write here 0, it can be anything. So what will be the degree here of this equation? What is the degree here?
2.
2.
Degree. So this homogeneous equation is of degree 2. If I am saying this one is this a homogeneous equation? Cot inverse y by x.
Yes, ma'am.
So what is the degree here?
1.
Why you are saying it is 1?
0.
If it is like this, it will be 1. T. But here tt gets cancelled. Suppose I will consider this one sine inverse y by x. What is the degree here? So I multiplied x, then we are getting degree 1. Here,
0.
0.
0.
because if you put ty, tx, tt gets cancelled. No power of t. At least if you look at the definition. Okay, so this is degree 0. Got it? So now we will come to the homogeneous differential equation. So homogeneous differential equation. Homogeneous differential equation. Okay, this is also the same thing, and this one is normal equation we are considering. Okay, so here if your differential equation, normally it will be of this form: m of xy dy plus n of xy dx is to 0, right? Dy will have some coefficients which involves xy, dx will have the coefficients which involves xy. This is the form of the equation, first order first degree equations. Okay, so when this will be homogeneous, when you can say the differential equation.
Degree of m equals to degree of
Degree
n.
of m is equal to degree of n.
Yes,
Same as degree of n.
same. Could you repeat? I couldn't hear you actually. What
Degree
you're
of m and
Degree
n
of
are equal.
mxy is equal to degree of nxy.
okay? So the coefficient of dx and coefficient of dy will have the same degree. And what about, are they homogeneous or not? Otherwise, how you will say about the homogeneous? Got it? Both these coefficients mxy and nxy, they are homogeneous functions. Okay, we have already and homogeneous equations. We have already discussed about these homogeneous equations of degree n. Okay. So here, like f of xy, this mxy and xy, they are homogeneous equations and they are of same degree. Okay, not only homogeneous, they also have the same degree. Okay, is homogeneous if m of xy and n xy are homogeneous equations functions of degree of same degree. This is important. So both the terms, not only of the same degree. I understand you mean it, but you have to see that it's homogeneous and it's of same degree. Okay, like you will say the equations of this form x square plus xy into dy plus y square dx. So these are the homogeneous equations. Okay, this is homogeneous. Okay, you can see each term is of degree 2. So how you can solve this equation?
Put y is equal to vx.
So put y equals to bx. It's a working rule for that one. Okay. So here you see this equation mxy dy dx. So we will simply write it dy by dx equals to. So it will m of xy and the numerator mxy in the denominator nxy, and we have a negative sign. Okay. So simply, as you said, we will be substituting here. So so the
Substitute y by x equals to t.
1 by x equals to t.
Y by x.
Y by x is
Okay.
equal to v or y is equal to vx. Both are the same thing.
Okay. Okay. Substituting y equals to vx. Okay. So if you substitute this one, you see dy by dx will be v plus x dv by dx.
Exactly.
Okay. So this also you have to substitute. Okay. Both sides. Then you can use, that variable separable method. So you can do that variable separable method. Okay. So here this will be reduced to, then reduce to variable separable form. Okay. So you see one example. So x square y dx minus x cube plus y cube dy equals to 0. So here you can try. Okay, dy by dx will be, you can see this is of degree 3, degree 3, they are homogeneous equations. So dy by dx, here if you see dy by dx, you take it to that side. Then here we will have x square y by x cube plus y cube. Okay. So here we have this. Now next thing is we will substitute y equals to vx. So we have, so dy by dx will be v plus x dv by dx. And here we have x square into vx, x cube plus v cube, x cube. Okay. So here we're left with v into 1 plus v. Okay. So you can take this v to this side and you can proceed further. So what will be the answer if you solve?
ln 1 plus y by x whole cube equal to ln x plus c.
Ln y. So can I write the answer directly or I will solve it? So here we will do the variable separable form. Okay. So this will be minus v4 by 1 plus v cube. Okay. So here x by dx, so we will take it to that form. So dv 1 plus v cube by v power 4, and here dx by x. So negative sign will be there. Further, you can put this, make it fraction 1 by v4 minus 1 by v dv. Okay, so then go for the solution. So here what we are getting is, so the solution becomes minus 1 by
minus
3
1 by
v cube. If you do the after integration, integrating, both sides, minus 1 by 3 v cube minus log v plus log v. So this is plus, I have written minus, this is plus. So here it is coming log v log x plus log c. So it is up to
Minus log x.
minus log x. So if you can now substitute, we have started with vx equals to y. So v will be y by x. Okay, now again we substitute this one and we have arrived here vx. This will be log vx by c equals to minus 1 by 3 v cube plus. So now Vx by C equals to e power 1 by 3 V cube. Plus 1 by 3 V cube. Okay. So if you want further, you can write y equals to y v equal, we will substitute here, then it will be Vy by x. So y by C e 1 by 3 y cube x cube. So it will be x cube by 3 y cube. Constant times exponential x cube by 3 y cube. Okay, so this is how you should get. Okay. Then, so we have also some idea about the some special forms of homogeneous equations. Okay. So if you have this form, you can directly use this one and reduce it to the variable separable forms. Okay. So if this is the form, okay, this is case 1. So here, one thing you have to make sure a by a dash not equals to b by b dash. Okay. So if this happens, that means they are not parallel, right? If a by a dash and b by b dash will happen, they will be parallel. Okay. What we are considering as the intersecting lines. Okay. Okay. So we will consider h and k be the point of their intersection. Okay. So that means pair of straight lines are intersecting. Intersecting. And if HK be the point of their intersection, point of intersection, then shifting the origin to HK. So they shift the origin to HK by setting x equals to h plus x. So now the given equation, if you substitute, the given equation will reduce to dy by dx x plus by. So dy by dx, okay, is small dy by dx equal to capital dy by dx from the substitution as h and k are soft constants. Okay, so now this is a homogeneous equation, you can see, and now it's a homogeneous equation. Okay, because we are able to get rid of this the constant. Okay, so now this is a homogeneous equation, and you can use the solution of homogeneous equation. It's a homogeneous equation. It's ordinary differential equation. So you can use the techniques of the homogeneous equation to solve this one. Okay. Um, I have also one more. Okay, you can see when we have parallel lines. Okay, instead of this. Okay, if a by a dash equals to b by b dash equals to lambda, that means we have there we have the uh, intersecting lines, and here we have the parallel lines. So instead of lambda, we can consider 1 by lambda. So the lines ax plus by plus c equals to 0 and a dash x plus b dash y plus c dash are parallel. So lines are parallel. Okay. So the symbol I have given for the parallel. Okay. Now you can write it this way. If a equals this one, a will be a dash by lambda. Okay. So dy by dx will be lambda into x plus by plus c. Now to solve the above equation, so to solve the above equation, we will substitute here. And what we will substitute for the intersecting lines, we are shifting the origin, and we are putting the small x as capital X plus k. And here they are parallel lines, so we will substitute z equals to ax plus by. Okay, so this term we are substituting because this term is same, so it will be z plus c by lambda z plus c. Okay, then what happens?
Ma'am,
Yeah,
in denominator it is C dash, right?
yes,
In denominator, lambda
yeah,
ax plus by C dash.
oh, c dust. Yeah, it's c dust, not c. So dy by dx will be z plus c by lambda z plus c dust. Okay. So now it is for a previous form is there. Okay, we can solve it now. Okay, so we will do one example. See, one example. Solve dy by dx equals to x plus y plus 4, then x minus y minus 6. Okay, so here this is if you look at the coefficient of x ratio and coefficient of y ratio, they are not same. A by a dash not equals to b by b dash, so they are intersecting one. So we will look at the case 1 situation. Okay, this one. So what we did there, we substituted. First we will go, we will shift the origin. Okay, so we put x equals to x plus h, y equals to y plus k. So dy by dx, okay, because constant difference is there. So now dy by dx, if you substitute there, dy by dx, and here we will have x plus y plus h plus k plus 4, and in the denominator we have x minus y plus h minus k minus 6. Okay, now we have to choose our h and k such that both the equation will be 0. Okay, then it will reduce to the normal form. Okay, choose h and k such that these two equation, they satisfy this two equation, h plus k plus 4 equals to 0 and h minus k minus 6 equals to 0. So we have two equations and two unknowns. So what are the value of h and k?
1 minus 5.
1 minus 5.
1 minus 5.
1 minus 5.
So 1 and minus 5. So h is 1 and k is minus 5. Okay. So here if these two are 0, so now our differential equation is this one, x plus y by x minus y. Okay. So now it's a homogeneous differential equation. Right, this one's homogeneous differential equation. You substitute y equals to vx, homogeneous equation. Okay, so now here substitute y equals to vx and solve this one. So solve it, and what is your answer? Anyone done? Tan inverse will come here. Anyone solved? Answer done.
ln x equals to
Ln x equals to
tan inverse v
ln x equals to tan inverse v
minus half ln 1 plus v square
minus half ln 1 plus v square
plus c.
plus c. So here we can take this tan inverse to one side so that we can use our logarithm. So here tan inverse, so we log x plus, so here it will be half will go up, so square root of 1 plus v square plus c. And for v you can substitute, and we already have the value of h and k. So tan inverse v is tan inverse y by x, capital Y by x. So hk already we have -1 -5. So tan inverse y plus 5 by x minus 1 log. Oh, we are considering ln. X will be x minus 1, 1 plus v square y by x, y plus 5. So ln x minus 1 square y plus 5 plus c. Okay. So let me give you one more. Then now you solve. Y plus 5 by x minus 1. Okay, so you see here the coefficients, the ratio of numerator and denominator, the x coefficient, y coefficient is 1. Okay, so the lines are parallel. So we will put x plus y equals to z. Okay, so now you can proceed. Okay. As a by a dash equals to b by b dash. It's coming 1. Solve it. So if you put here dz by dx minus 1, two into z minus 1, z minus 6. So dz by dx, so what will happen then? Not minus 1, it's adjusted. Okay, after adjustment only you will be getting this. Variable separable you can do. One side z,
Man, I consider x plus y plus 4 equals to z, then
y plus 4.
equals to z, then denominator z minus 10.
Why y plus 4? The, like what
No,
I
no, no,
said,
x plus y plus 4
x plus y.
means whole numerator I consider z.
No, we don't consider z. See the case 2 I told you, no? Here. The first one, when they are intersecting, this ratio a by a dash and b by b dash not equals to this, we will simply take this hk, substitute, and such that this equation becomes 0. We will be getting this one. Okay, this is a homogeneous PD, and if you have this situation, parallel lines, the coefficients a by a dash and b by b dash is 1 by lambda constant, then you will substitute z as ax plus by here. This is the situation. Okay, when this is not equals to 1, we shift the origin and solve it. If it is equals to some constant, we will be considering ax plus by as z. That's what we are putting. X plus y, here a is 1, b is 1. So we are putting this much. So dz equals to 2 dx. This is z minus 1. So you can further do this, z minus 1, 1 plus 5 by z
5
minus
by
1. 5 by z minus 1, and this is dz equals to 2 into dx. Now integrating.
Excuse me, ma'am.
So how much you are getting after integrating?
मैम
z
डेट 1 - z - 1 होगा ना
1 minus minus z minus 1, and here we have 2x plus the constant c. Then it's done. You can substitute z. We have substituted as x plus y. So here x, if you come this way, it will be y minus x. Okay, 2x, and this is z. Z is x plus y. Okay, so if you substitute now and 2x, you come to this side, it will be y minus x. Then 5. Okay. So now you know variable separable method, and for homogeneous equation, two cases we have discussed. And now one is exact equations. Remember what is exact equations? So we will talk about exact differential equation. So what is exact differential equation? Anyone remember? So normally our differential equation, they said this is the form. Okay, this nxy dy. So this is the differential equation. Okay, first order, first degree. So when this is exact, you, any of you can say, you know, some of you know, I know. So if there exists a function u of xy such that the total differential of u of xy, it's same as this differential equation. Okay, that means you can express this differential portion, okay, as the exact differential of a function. Then it will be an exact differential equation. And we have some derivation with where some formula also where you can check whether it's a exact differential equation or not. You can further write. Okay, as I said, that is the LHS, left hand side of equation 1, can be expressed as the an exact differential. So here, if you consider y dx minus x dy, is it exact? So it's not y dx minus x dy, you cannot express it. But if you say y dx plus x dy, see, if you put the example y dx plus x dy, this is the total derivative of xy, right? So this one is exact. Now if you have minus sign here, it won't be the exact. Okay, not exact. So we have a formula where you can check whether this is exact or not. Okay. So the differential equation is exact if and only if
Ma'am, this means mxy is a partial differentiation with respect to x, and nxy is equal to partial differentiation with respect to y.
then
No, I'm just telling, is this, can you interpret this in this way?
yes. So what did you say? Could you repeat?
Ma'am, mxy equal to partial differentiation of the f of x with respect to x,
Uh,
and
Wait,
nxy
wait, wait. Mxy is. Are you saying mxy is the partial differential equation of
partial differentiation of f of x with respect to s. X.
m by what? With respect to what?
Ma'am, mxy is equal to partial differentiation of f of x with respect to x.
Where is what is f of x here?
F of xy,
I don't see
the
about f of
exact
xy. F.
the
This example you are talking about f of xy, that will be the solution y equals to fx.
yes, ma'am.
But this is your differential equation. Okay, whether it's exact or not, you have to find. Okay, so it's exact if and only if. Okay, both necessary. When this the partial differential of m with respect to y, it's same as the partial differential differentiation of n with respect to x. Okay, what it is saying that if you differentiate partially the coefficient of x with respect to y, it is same as the partial differentiation of the coefficient of y with respect to x. Got it? This is the coefficient of x. We differentiate it with respect to y, and that is if that is equals to the partial differentiation of n. That means the coefficient of y with respect to x. Then it's exact. Or we have this standard method, like I said, the previous one. You see, you can express it as the differential of a function, exact differential form. Okay, then it's also exact. Okay, this is the situation. You can also use this one here. Y, if you differentiate it y1, and this is also x, differentiation with x will be 1. So this is satisfying. So it's the exact differential equation. See, one example I'm giving you. So solve the differential equation. X cos y.
Ma'am, we have to solve it or show that it is exact or not.
You have to show that exact or not. Okay.
And
Later on, we will have the methods to find the solution for the exact differential equations. Okay.
in the question it was written solve that way.
Okay. Okay. Sorry. If it is exact. Okay. You solve. Try first. You show that it is exact or not. If it is exact, you can solve it. Is it exact?
Yes, ma'am.
Okay. Then
Yes, ma'am.
how we solve it? Any of you remember? I know some of you know how to solve the exact differential equation. Okay, we will discuss next class. Okay. But
Ma'am, we
Tuesday we
will
have a,
multiply and then we will one term we will integrate.
is it possible once you have shown? Okay.
Ma'am, we
Um,
can open the brackets and bring the common terms
Ma'am,
together
y
that we
dx
can
plus x
find
dy
which will.
like that we will y dx plus x dy you can write like.
Make an arrangement such that it becomes a perfect differentiation.
Yes, ma'am. Ma'am, differentiation not of a means another term of a plus b like that we will differentiate like. We'll
See,
arrange the term.
there is one thing, at least by the formula, we are able to show that it's an exact differential
Yes,
equation.
ma'am. Like
So,
one.
no, no, so there must be some u of xy, right? There must be some u of xy
Yes, ma'am.
where it is, since this is exact, so there must be, okay. For the solution, it's an exact, okay, exact. The equation is exact. Okay, so LHS must be the exact differential equation of some form. Okay.
Yes, ma'am.
So what you think if you do integrate, what you are getting? U of xy will be, it will be of the form something like that. Dx. Okay, if you integrate this one form will be this one and the constant will be dependent on y. Okay, since we are doing the integration, so this will be the thing. Okay.
Ma'am, is this be partial integration or only integration?
To find this cy, we will see. Okay, I will tell you next class. Do you have any other class now?
Lab, ma'am, after this.
Yeah.
Yes, ma'am. We will.
Okay, okay, go for the lab. Okay. See, Tuesday we have a class, right? Can we shift this to Monday? I mean, it's for your convenience, I am saying. Otherwise, I will take it on Tuesday. This exact up to exact will come, okay? Because up to this only I have finished. Exact and this integrating factors are there.
Ma'am, Monday at what timing?
You say you have classes, right? Okay, let me see. Okay, if I can interchange with any of the profs. Okay, it's a
Ma'am,
all
ma'am, it would be okay if we inform you by today evening.
you will inform.
Yes, ma'am. Yes, ma'am.
Okay. Only thing I want to prepone so that you will have time. Okay.
Yes,
Otherwise,
ma'am.
I will take on Tuesday. Okay.
Yes, ma'am.
Like you don't have time, but don't keep it on 12 to 1. I have a class during that slot. Okay. On Monday.
Okay, ma'am.
Okay. Other classes I will arrange. Okay then. So I'm ending the class. So first module completely and this one. Okay. Exact I have started and I will do some problems next class. Okay. Bye.
Now after exact integration.
This much only I have completed.
Okay.
I'm supposed to complete 2 modules before your midterm. It's okay, okay, fine. So I'm ending the class, okay.
Thank you, ma'am.
Thank you, ma'am.